welcome dear students. We are in the series of the quantum technology. In this series today we will discuss the quantum batteries. What are the quantum batteries, how we use the quantum batteries, then how it works, what is the principal point behind the quantum batteries, moreover how many types of quantum batteries we have, and we will discuss in brief all the types of quantum batteries, and after that we discuss about its application and its uses. First we discuss about the quantum batteries. You all know that the battery, that is the device that store the energy. So quantum battery is no exception. It means it also store the energy. Now how it is different from the conventional batteries? The quantum mechanical system. Yes, it uses the quantum mechanical system that stores the energy of photons rather than the electrons and ions. So as is the case with the conventional electrochemical batteries which stores the electrons or ions, but these quantum batteries stores the photon rather than the electrons and ions. Unlike normal batteries, quantum batteries charge faster as their size increases thanks to the quantum effect such as entanglement and superposition. From the very beginning we are discussing about the quantum technology, and in this technology we are discussing the 4 points. First is the entanglement, second is the superposition, third is the coherence, and fourth is the interference, that, and fifth is the decoherence. So we discuss these features of the quantum technology. Similarly, we apply these features in the quantum batteries also. So these battery follows the quantum effect such as entanglement and superposition, a property that could prove useful in making the more efficient light harvesting devices. Why we are calling it as a light harvesting? Because we are using the photon as a storage. So it is a light harvesting devices, or we can say for example like a solar cell. Now the quantum batteries have the potential to accelerate charging time and even harvest energy from the light. Unlike the electrochemical batteries that store the ions and electrons, a quantum battery stores the energy from the photons. Photons, quanta, that is the packets of energy. It is in the form of the light. So quantum batteries charge faster as their size increases, and that thanks to the quantum effect such as entanglement and the superposition. So by using these features, quantum batteries charge faster as that because they just follow the quantum effect. They will not be able to power electric vehicles, but could improve the efficiency of the solar cell as we used for small electronic devices. Ultimately, the challenge is to evolve these batteries, as these devices could serve as a true small off-grid power sources. Nowadays, the advancement of the quantum technologies such as quantum information, computation, simulations and the sensing calls for novel and specific platforms for the energy storage. So, quantum devices require solution for energy storage, and energy provider components that should be highly compatible with their unique architecture and capable of supporting the creation of a superposition of the quantum states. So the need for specialized energy storage units for reversible quantum operations has been recently highlighted. So quantum batteries are the device that use quantum effect to leverage enhanced efficiency over the conventional battery technology. As we are dealing with the highly fast systems, so we require the efficient battery systems also. So quantum batteries are devices that use quantum effects to leverage or enhance the efficiency over the conventional battery technology. So now, while research into these fascinating systems is still in its infancy, so quantum batteries are poised to revolutionize energy storage as we know it by offering the high energy storage capacity. Another, faster charging rate and longer battery lifetime compared to the conventional batteries. So when we talk about the quantum batteries, then we just keep in mind that it must offer the high energy storage capacity, moreover faster charging as well as the longer battery lifetime. So quantum batteries have implications for the various applications including electric vehicle, renewable energy system and the portable electronic devices. Most importantly, recent results in the fundamental quantum information theory have suggested that quantum batteries are mandatory in realizing truly reversible quantum gates for quantum computers. So, quantum batteries, that is also known as a QB, first introduced by Alki and Fens in 2013, that have emerged as an intriguing approaches to energy storage. So, quantum batteries are a device that are made of quantum system and they fundamentally quantum mechanical effect follower to charge, to store and to release energy. So, quantum energy that follow the quantum mechanical effect to charge, to store and to release energy. Means we just want that type of batteries which charge faster and discharge at a slow rate. So, that is the most important feature of the quantum batteries. So, quantum batteries can be charged or discharged through operation that established coherent superposition among the various states. We are not talking about the single state, but we are talking about the various states. So, it establishes coherent superposition among the various states while the energy is stored in the excited state of the quantum system. So, entanglement effect and the non-classical correlations have been shown to lead to super extensive scaling of the charging power, that is the ratio between the stored energy and the charging time. So, with the quantum advantage compared to their classical counterparts. So, these devices take advantages of quantum particles which, unlike classical particles that have defined properties and can simultaneously be in the superposition of the several states. That is why there is an interference. So, these devices must take the advantages of simultaneously superposition of several states. Now, quantum particles can also influence other isolated particles with the state of one instantly influencing the state of others regardless of the distance between them, that is the entanglement. So, the phenomena that is known as entanglement allows a quantum battery to recharge more quickly. As the greater the number of entangled particles, the faster they collectively move from a lower energy state to the higher energy state. How it is possible? It is only possible that the isolated particles with the state of one instantly influencing the states of the others regardless the distance. Means they are entangled with each other. So, they forming the low energy state to the higher energy state. Now, what are the aspects of the quantum batteries? Number first is the rapid charging, or we can say what are the features of the quantum batteries. First is the rapid charging, fast charging. Quantum mechanics allows for collective behavior where all the particles in the battery absorbs energy simultaneously, that is a superposition. That means that more particles can lead to the faster charging rates unlike the conventional battery because they are simultaneously absorbs the energy. So, particles absorb the energy simultaneously and they are charging faster. Another is the experimental prototype. Researchers have successfully created the lab scale devices. So, in 2025, development demonstrated a device using the organic material in the microcavity that could hold the energy for the microsecond, that is significantly improved over the nanosecond, that is a dark state. Another is a high efficiency and durability, that is a another feature for the quantum batteries. These batteries are expected to have near perfect efficiency and suffer from little to no chemical degradation, allowing them to potentially be rechargeable millions of times. Another is a potential application of these battery. While currently far from powering electric vehicles, they are poised for the future application in the quantum communication, in the quantum computers, and high efficiency solar energy harvesting. It will be used, and the small scale ultra fast charging devices we can use the quantum battery. Another is the current challenges. The primary challenges include the scaling of the technology from the molecular level prototype to the practical devices and preventing energy from the leakaging. So, leaking or the self discharge should be avoided in this quantum battery so that it will remain for a longer time. What is the principle behind the quantum battery? As we are discussing, that it based upon the quantum effect. Quantum effect means superposition and the entanglement. So, the idea behind the quantum batteries is rooted in the particles of the quantum mechanics, that is the photon, and that is based upon the quantum mechanical principle, which govern the behavior of the particles at the atomic and subatomic level. Whenever we talk about the quantum, then we are talking about the particles at the atomic and subatomic level. So, quantum effect such as superposition and entanglement may be used to enhance the storage and release of the energy in the battery system. So, one of the key concepts in the quantum batteries is the use of quantum superposition of energy states. Superpositions means when we are having the maximum intensity or maximum energy at that state. So, in classical batteries, energy is stored in the discrete state, but in the quantum battery, energy could be stored in the superposition of multiple states simultaneously. Right? What is the difference between the conventional and the quantum batteries? That energy is stored in the discrete state in the classical, but in the quantum the energy is stored in the superposition of the multiple states simultaneously. So, this could allow for a higher energy density and potentially increase the amount of energy that can be stored in the system or in the batteries. So, another concept is the use of quantum entanglement. Superposition means we are using the two phenomena. First is the superposition, second is the entanglement. Superposition when we are having the quantum batteries where the energy could be stored in the superposition of multiple states simultaneously, and that would allow the higher energy density and potentially increase the amount of energy that can be stored. Another concept is the entanglement. So, quantum entanglement where the particles become correlated in a way that their properties are linked. Means we are just correlating the particles, is not related to the distance, but they are related with the each other. So, this could enable the transfer of energy between the quantum batteries without direct physical contact, potentially leading to the more efficient energy transfer and reduce the energy losses. So, first model of this type of quantum battery was developed in the laboratory, and it was proposed by the Ferrero et al., consisting of the solid state devices that obtained by the coupling N, capital N, two level system, that is a TLS, to the optical mode of a cavity. So, for this you can have the reference, and from this reference you can find out the first model of the quantum battery that is fabricated in the laboratory, where they just used the coupling of N two level system for the development of the optical mode of the cavity. So, the charging power of the device, which was dubbed like the QB was shown to display the superlinear scaling with the root and improvement resulting from the collective behavior mediated by the cavity field. So, it opens the interest perspective for the energy storage devices that can be charged faster. So that will be taken from the first development of the first fabrication of the devices. So, the quantum batteries have been proposed that store the energy in the form of photon instead of using the electrochemical reaction. So, the quantum battery would be charged using the phenomena of the entanglement and superposition. So, electrochemical batteries, if we talk about, the cell are charged independently. In the quantum battery, cells are collectively charged. So, the improved performance of collective versus parallel charging is called the quantum charging advantage. So, if we take the example like a battery packed with the 200 cells, and the quantum charging would be 200 times faster than that of the conventional charging, because these cells are simultaneously in the parallel charging. So, using the same power level available with the small home charger that takes 10 hours to charge, an electrochemical battery pack could charge a quantum battery pack in about 3 minutes. How surprising it that it is taking the conventional battery taking the 10 hours to charge, but here the quantum battery taking only the 3 minutes to charge. How fastly these batteries are going to be charged. Now you can see with this diagram that here we are having a conventional battery on the left hand side charged and that are charging the battery, and right hand side we are having the quantum batteries. Classical batteries, they are charged one by one, but simultaneously the quantum batteries are charged, and they are charged faster as compared to the conventional battery. The cell in an electrochemical battery charge independently, as we have seen that these all are charging independently. But here on the right hand side, while the cells in the quantum batteries are entangled and collectively charged, all these are collectively charged. That has been taken from the APS physics reference. The use of the quantum mechanical principle can result in the EV battery state of the charge sensors with much higher accuracy, reducing range anxiety, and other types of the quantum sensors can be used to end line testing of the batteries in the gigafactory, speeding production and reducing the cost. Further, the quantum batteries have been proposed that can be charged significantly faster than that of the electrochemical batteries. Now, quantum batteries to date have primarily been studied from a theoretical point of view, evidencing many unique properties, while various experimental designs of the quantum batteries have been proposed. Only a few primarily yet significant steps towards the practical demonstration of the fully operational quantum batteries have been reported. So, these steps include the demonstrating the super absorption properties in the microcavity with the organic molecules, that using the ultra fast pump probe spectroscopy, energy storage in the single spin quantum batteries for up to the 2 minutes, and experimental investigation of charging as well as discharging and storage capacity of the quantum batteries based on the single qubit. So, the explores other materials including the inorganic nanostructures, or we can have the perovskite systems as well as we have a superconductors. So, we have many type of materials that are used for the production of the quantum batteries. That may be the inorganic, organic materials, that may be other type of quantum well or quantum dot we can take as a nanostructures, and moreover we have normal high temperatures like the supercapacitor. So, after introducing the main properties of quantum batteries and the different scheme proposed for their implementation, so we present overview about the material that are potentially suitable for the realization of the some quantum battery architecture. The first, we have the microcavity with organic molecules and inorganic nanostructure such as quantum well as the quantum dot, which highlighting highlighting examples where either strong light matter coupling or collective effect are demonstrated. Another is include the microcavity with perovskite material and superconducting circuits. So, strange metals are potential materials for the implementation of these exotic batteries. So, other quantum coherent systems such as trapped ion, Rydberg atom and ultra cold atom, for which the recent reviews and perspective articles are already available, and that will be used for the quantum batteries. So, finally, we will discuss some of the critical aspects of achieving a fully operational and some possible and promising future research like this. If we talk about the quantum mechanical system in the quantum battery with a non-zero energy bandwidth, whose Hamiltonian H naught can be written as a sum of the capital and local terms, like each described by a microscopic Hamiltonian Hi. So, collectively we will take it as H naught is equal to I1 to N, that is Hi, all microscopic Hamiltonian terms. So, N an ensemble of TLS for example is the simplest form of the quantum batteries one can think about it. So, in this case is H, that is a physical represents the microscopic Hamiltonian of each TLS. So, in contrast to classical batteries, quantum batteries can be acted upon via unitary operation that may create at least temporarily non-classical correlation between the capital and sub units. As in the case of any other batteries, 3 operational stages can be defined: a charging, storage and discharging stage, where work is extracted from the battery. So, in the charging state of the non-equilibrium dynamics, one switches on a interaction H1 in a time window of the duration, particularly that is defined by the T, in such a way to inject energy into the battery, that is a charging. Just switching an interaction Hi in the time window during the Ti just to charge or just to inject energy into the battery. This can be done provided that the commutator. So, H naught H1 not equal to 0, a condition that is essential for charging the actual quantum battery, which is mathematically described as the Hamiltonian H naught. Under the action H1, the state rho t of the battery changes according to the time dependent Schrödinger equation. So, real devices of course are always open quantum system, and therefore, this closed system Hamiltonian description needs to be modeled according to the actual laboratory effects by using the theory of open quantum system. In this respect, theoretical results have been recently reported by the considering the state that are protected from the environment. So, a more detailed discussion of the open quantum battery can be found and reference can be found through there. So, finally, mention another important figure of the merit, which is the physical measuring of the maximum amount of the work that can be extracted from the quantum battery in a cyclic process such that the Hamiltonian of the system is the same as that of initial and the final state. Moreover, the charging and discharging phase of the quantum batteries are dynamic processes that can be specifically controlled to enhance the device figures of the batteries of the system. So, further we will discuss regarding its type and how they are useful. Thank you very much.